Right now, in the time it takes you to watch this sentence, approximately 25 million toilets just flushed around the world. Each one sent between 6 and 13 liters of water swirling down a pipe and out of sight. You pressed a button, the bowl emptied, and you never thought about it again. But that water didn't vanish. It's still moving right now, beneath your street, beneath your city, through a network of pipes so vast that if you laid them end to end, they would wrap around the earth multiple times. And the journey that water takes from your bathroom to its final destination is one of the most engineered, most expensive, and most disgusting processes in modern civilization. This is where your flush actually goes. The first 3 seconds are simple. Gravity pulls the water down from your toilet into a smaller pipe inside your building, usually about 10 centimeters wide. That pipe joins other pipes from your sinks, your shower, your washing machine. Everything liquid that leaves your home merges into a single line called a lateral, and that lateral connects to the public sewer main running beneath your street. At this point, your flush is no longer yours. It has joined a river of wastewater from every building on your block, every apartment, every restaurant, every office, all of it flowing together in a pipe you've never seen and probably never will. Gravity does most of the work. Sewer systems are built on a slope, tilted just enough that the water moves on its own, roughly 2% grade, a drop of about 2 centimeters for every meter of pipe. Engineers calculated these angles more than a century ago, and the principle hasn't changed. The pipes get larger as they collect more flow, from 10 centimeters under your house to trunk sewers that can be 3 meters wide or larger, big enough to drive a car through. In cities like London, Paris, and Tokyo, the oldest sections of the sewer system are essentially underground cathedrals, brick-lined tunnels built in the 1800s that are still carrying waste today. But gravity has limits. In flat cities, or in areas where the terrain dips and rises, the water can't flow downhill forever. That's where lift stations come in. These are underground pumping facilities scattered across the city, usually disguised as unremarkable concrete boxes on street corners. Inside, powerful pumps push the sewage uphill to the next section of pipe, where gravity takes over again. A major city might have hundreds of lift stations, running around the clock, consuming enormous amounts of electricity, all to keep a river of human waste moving in the right direction. If a lift station fails during a storm, sewage backs up. And when sewage backs up in a city, it doesn't stay underground. It comes out of manholes, storm drains, and in the worst cases, back through the pipes into people's homes. A basement flooded with raw sewage is one of the most common and most devastating infrastructure failures in the developed world, and it happens thousands of times a year. Now, let's talk about what's actually in the pipe. Your flush is water, yes, but mixed into it is everything a city sends down its drains. Human waste, toilet paper, soap, cooking grease from restaurant kitchens, food scraps from garbage disposals, hair, dental floss, medications that people flushed instead of disposing of properly, and an increasingly massive problem that the industry calls fatbergs. A fatberg is exactly what it sounds like, a solid mass of congealed fat, oil, grease, and non-flushable items like wet wipes, cotton swabs, and sanitary products, all bonded together into a rock-hard blockage that can grow to the size of a bus. They form slowly, layer by layer, the way a stalactite grows in a cave. Except instead of minerals, it's cooking oil and baby wipes. In 2017, workers in London discovered a fatberg beneath Whitechapel that was 250 meters long and weighed more than 130 tons, heavier than a blue whale. It took crews 9 weeks to break it apart with high-pressure hoses and hand tools, working in toxic fumes in a tunnel they could barely stand in. A piece of it was put in the Museum of London, where it is still on display, slowly decomposing behind glass while visitors stare at it in horrified fascination. Eventually, all of this arrives at the wastewater treatment plant, and this is where the real engineering begins. Treatment happens in stages, each one removing a different category of contamination. The first stage is screening. The raw sewage flows through metal grates that catch large objects. The things that these screens pull out of the water would shock you. Rags, plastic bags, toys, phones, jewelry, dentures, and animals. Rats, snakes, and in documented cases, Alligators. Workers at treatment plants joke that they've seen everything. They're not exaggerating. After screening, the water enters primary settling tanks, enormous circular basins where the flow slows down and heavy solids sink to the bottom. This sludge is scraped off and pumped away for separate processing. The water that remains, still dirty but now free of the heaviest material, moves to secondary treatment, the biological stage. Here, engineers deploy a weapon that is both ancient and brilliant: bacteria. Trillions of microorganisms are introduced into the water in aerated tanks, and these bacteria eat the dissolved organic matter, the invisible pollution that makes sewage dangerous. The bacteria consume the waste, multiply, form clumps called floc, and settle to the bottom, taking the pollution with them. It's controlled rotting on an industrial scale. And it works remarkably well. In advanced treatment plants, a third stage follows: filtration through sand or membranes, chemical disinfection with chlorine or ultraviolet light, and in the most modern facilities, reverse osmosis, the same technology used to desalinate seawater. By the time the water exits the final stage, it's clean. Not metaphorically clean, analytically clean. Cleaner, in many cases, than the river or lake it's about to be discharged into. And here's the detail that makes most people uncomfortable. In a growing number of cities, that treated water doesn't go to a river. It goes back into the drinking water supply. This is called direct potable reuse, and it's exactly what it sounds like: toilet to tap. The wastewater from your flush is treated, purified, and sent back through the drinking water system to come out of your kitchen faucet. Singapore has been doing this for over 2 decades with a product they branded NEWater. Windhoek, the capital of Namibia, has been drinking recycled wastewater since 1968. Parts of Texas, California, and Australia are implementing or expanding similar systems right now. The water is safe, the science is settled, the testing is rigorous, but the psychological barrier is immense, and water utilities know it. They've spent millions on public education campaigns trying to convince people that the water in their glass is not, in any meaningful sense, the water that was in their toilet 3 days ago. Chemically, it's not. Emotionally, good luck. And then there's the sludge. Remember the solids that settle to the bottom of those tanks? That material has its own journey. In many treatment plants, sludge is pumped into anaerobic digesters, sealed tanks where bacteria break it down in the absence of oxygen, producing methane gas. That methane is captured and burned to generate electricity, often enough to power the treatment plant itself. The remaining solid material, now called biosolids, is dried, tested for contaminants like heavy metals and pharmaceuticals, and in many regions trucked to agricultural fields and spread as fertilizer. The food you ate became waste. The waste became sludge. The sludge became fertilizer. The fertilizer grew new food. And somewhere, right now, a farmer is spreading processed human waste on a field that will grow the wheat that becomes the bread on your table next month. The cycle is complete. And most people eating a salad have no idea they're sitting at the end of it. The next time you press that button, remember this: you're not making water disappear. You're handing it to a system that employs thousands of people, runs around the clock, and performs a chemical and biological transformation so thorough that the water comes out the other side cleaner than it went in. Every flush is the beginning of a journey through underground rivers, bacterial armies, and engineering so quietly brilliant that civilization literally depends on it and never thinks about it once. But flushed water isn't even the strangest transformation that happens when humans stop paying attention. Right now, there are entire cities standing empty, streets with no cars, buildings with no people, schools with books still open on the desks. When every last resident leaves a city, nature doesn't wait for an invitation. It moves in, and what it does to concrete, steel, and glass over the years is both beautiful and terrifying. That story is next. And if you don't want to miss it, you know what to do.